Amazon Bedrock is a fully managed service that offers a choice of high performing foundation models from leading AI companies. Bedrock requires different foundation models to be enabled before they are used. So let's start by enabling the models that we need for this demo. Here, we can see the available models from different providers. For this demo, I've enabled Amazon's Titan Embeddings G1 text model for generating vector embeddings and the Claude model from Anthropic for natural language queries. Next, I will load some example product data into a DynamoDB table. OpenSearch pipelines will move this data into OpenSearch service in the later steps. This is the data that we're loading into Amazon DynamoDB, and we will call the DynamoDB batch write API through Python to load this data into DynamoDB. Here you can see in the console that the data we have successfully loaded. Now that we have the required prerequisites, we're going to configure the integrations between services. You'll first set up ML and pipeline connectors in OpenSearch service, followed by a zero ETL connector to move data written to Amazon DynamoDB to Amazon OpenSearch. Once these integrations are set up, we will be able to write data into DynamoDB and then automatically have that data available to query in other services. I'm going to use the request library in Python to call post and put requests that are authenticated with AWS Signature version 4, which is a standard authentication mechanism used by AWS services. I have stored my credentials in a JSON file and passed that to a library that generates my authentication header for all of my API calls. The first API I'm calling is to create a connector to Amazon Bedrock. OpenSearch provides connector blueprints for several ML platforms and models, so you are not limited to Amazon Bedrock. Here, I'm also passing the required parameters specific to the model that I'm calling. I am then capturing the connector ID into a Python variable. Next, I'm going to register a model group. ML models are organized into model groups or a collection of versions of a particular model to simplify access control. Next, I'm going to register a new ML model within OpenSearch and specify the connector ID to Amazon Bedrock and the model group ID we created in the previous API call. I will store the model ID into another Python variable. Now, let us verify that we have the different component IDs, and then we can call the API to deploy this model. With the model deployed, OpenSearch can now leverage Amazon's Titan embedding model for processing text data. An embeddings model is a type of machine learning model that converts complex high-dimensional data like text or images into lower dimensional vector representations, or also called embeddings. Let us test this model by providing an input text and see how this is converted into an embeddings. The embeddings represent the essential meaning or context of the input data. In this demo, the embeddings will encode the semantic information present in the product descriptions. Next, we'll create the details table mapping pipeline. These pipelines allow OpenSearch to pre-process and enrich data as it is written to the index by adding embeddings through the Bedrock connector. Now, let us continue creating the zero ETL integration in the Amazon OpenSearch Service console. Let us go to Ingestion Pipelines, click Create Pipeline, and select Zero ETL with DynamoDB. Let us select this blueprint and put a name against this pipeline. And here we can specify configuration of our Zero ETL pipeline. We will need to specify the DynamoDB table ARN, the S3 bucket name, as well as the region. and the IAM role that will be used by this integration. We have to ensure that this role have the right permissions to the different components. We also need to specify the host URL of Amazon OpenSearch. I already have this configuration pre-prepared, so I will just copy that in here. And then I will scroll down and leave everything else with the default and click Next. Now, let us review that and click Create Pipeline. It will take a few minutes for this zero ETL pipeline to be created. After the pipeline is created, it will take some additional time for the initial full ingestion of data from DynamoDB into OpenSearch service. Now that we have built our pipeline and our data is replicated from DynamoDB into OpenSearch service, you now have a few options of how you want to query your data. We can go to DynamoDB if you want to look up for specific key value pairs like product IDs. And you can use OpenSearch for keyword search queries. Here, we specify our search terms and we see the relevant responses. You can also see the embeddings that are generated as the data is processed through the zero ETL pipeline. We can then use these embeddings to find products with similar textual context. Instead of using keyword search, we can invoke a neural query to OpenSearch, and after retrieving relevant products, the script uses Bedrock to generate a more sophisticated response through the Claude model with relevant prompts so the model could simulate a response of a shopping assistant. Here is a sample question, and here is the response from the AI shopping assistant with some relevant products from our product catalog stored in OpenSearch.